All right, so now we're getting into learning how to solve a quadratic equation. And so we will be specifically cover three major methods of how we can solve a quadratic equation. Okay, but before we get really into any of the methods, I said earlier that I have to be clear. Before we can really use any of the methods being later taught right here, then the quadratic equation, assuming you know what it is, must be already put in the standard form. So ax squared plus bx plus c equals 0. And so that's at the bottom line before we can start with any of the methods being taught that follows with this. Then we have to put our quadratic equation in a standard form. So this form right here is called the standard form. All right. So we must put our equation before we can start using any of the method to solve the equation, the quadratic equation, into the standard form. All right, so now allow me to introduce one among the three methods of solving a quadratic equation, and that method here is called, we're solving a quadratic equation by completing the square, or sometimes you may hear people say the complete the square method right here, okay? But then that's the idea, it's one among the three major methods of how we can solve a quadratic equation. Okay, and so now allow me to bring in an example, and throughout the example we are going to learn the how-to instruction along the way with that. So now let me call that example 1. All right, so now we come to our first example here, and throughout this example I will illustrate the idea of how we can solve a quadratic equation by completing the square. Okay, and so what we have here, yes, it's a quadratic equation in standard form. So I have to make it clear that just like how I introduced prior to getting into any of the techniques right here, then we must be able to put our quadratic equation into the standard form before we can fire up any of the techniques right here. So the method we're about to use here is called the complete the square. But before we can use the method, before we can let the method be applied, we have to put our equation in standard form. Okay, and so now standard form in this case right here is ax squared plus bx plus c equals 0. Okay, and so our equation here, in the way I'm seeing it, the x squared minus 7x plus 12 equals 0. And how I said it was already in standard form here simply because now it's in the form of a coefficient. So our coefficient with the x squared here is 1. So I can easily note that down. So a is 1. See, the coefficient with the x squared term is 1. The b for our equation here is minus 7, because simply minus 7 here is the coefficient that comes with the x term. And c in our current equation here is 12. Okay, and so I just want to make clear how we can recognize our equation is already in standard form. Okay, and so now after recognizing how our equation is already in standard form right here, allow me to bring out one more important detail about this specific method, the complete the square method right here. Now, the complete the square method is best used when our quadratic equation in standard form has a leading coefficient 1. And I have pointed out and written it down on the board here earlier, and sadly I had to erase it, but the leading coefficient, the coefficient that comes with this x squared term, is a 1. And so once again, my bottom line is the method we're about to do right here, about to learn and apply right here, that's so-called the complete the square method, is best used when our equation in standard form and with coefficient 1. Lead coefficient equals 1. That's something to remember. Okay, so it's the method here, the complete the square method, is only best used when our equation is in standard form and with leading coefficient being 1. Okay, and so now let's get started into the methods right here. So now with our equation at start being a standard quadratic equation with leading coefficient 1. 7x squared minus 7x plus 12 equals 0. The first step I'm about to do here, I am going to subtract the constant term from both sides. So in here, our constant terms of this equation here is a 12. I'm subtracting that from both sides. And that's producing x squared minus 7x equals negative 12. And once again, you don't need to wait until this class to find out the reason why. It was simply because now the 12 got canceled on the left-hand side, and the negative 12 added together with 0 give me a negative 12. So our resulting equation at this point is x squared minus 7x equals negative 12. Okay. Now the next step here, even though it's the second step, but the more important step and the most attention-catching step here in order to complete the square. Now, with our current equation at this way right here, at this point right here, the way how it reads, x squared minus 7x equals negative 12. Now I am going to add to both sides. I'm adding to both sides 49 over 4. I'm adding 49 over 4 to both sides. All right. And so there are so many ways, many instructors explain about this number right here and call this number. I personally call this number to my students the magic number. Okay, it's the magic number. Because right now, you know, at this point, anyone viewing this lesson is feeling a little shocked of why I decided to add this number. I mean, there are so many numbers that we can add to both sides of our equation, because from what we've learned in algebra up to this point, we can add any number. We can add the same number to both sides as long as it's the same number, but then it can be any number. We can add to both sides, and equality remains the same. But why specifically 49 over 4? Okay, so once again, make clear notes that minus 7 here is our b coefficient for the x term right here, and our equation was already in standard form with leading coefficient 1. All right, so now let me give a quick explanation. With our equation being x squared minus 7x plus 12 equals 0. I just need to remind anyone, this is our b value. B equals negative 7. Okay, and so the 49 over 4 that I decided to add to both sides of the equation that you have seen on the other board earlier, that came from the square of minus 7 over 2. Okay, this 49 over 4 that I call the magic number, or sometimes I don't even call that. I'll just do it, and many other instructors having different ways of calling it. And so this magic number here came out from the square of minus 7 over 2. Okay, but then what is the generality of this magic number? The generality of the magic number here is that the magic number that we're adding is going to be, see, minus 7 that we are seeing right here in my setup that I'm showing right here. It came from the coefficient b from our middle term right here. So the magic number really is just the following formula: b over 2 all squared. That's the quantity, that's the value, that's the magic number you're adding to both sides of your equation in this current step right here. And so let's summarize what has happened up to this point right here. From our starting equation, I subtracted the constant term from both sides. Then the next step, I added that magic number, which came out from b over 2 all squared, or which came out from the square of b over 2. I added that to both sides of our equation. And so now it's, after doing that, and after being clear and being explained thoroughly with that step right here, the equation now becomes x squared minus 7x plus 49 over 4. That equals, now adding 49 over 4 with 12 right here, you need to do some fraction math, but it will come out being 1 over 4. 1 over 4. After adding 49 over 4 with minus 12. All right, and so now at this point, our equation currently at this step has become the following: x squared minus 7x plus 49 over 4 equals a constant value 1/4 on the right hand side. That's what we have produced at the most recent step from the other board. And so now I had a lesson prior to this video lesson about how we can recognize this particular setup on the left hand side here as a perfect square. Okay, as a perfect square. You can go ahead and review from that lesson of mine like that. But now from that lesson, allow me to just connect with that lesson right here. Then this particular setup from the left hand side now is written as a perfect square. X, the b over 2 that we've had with the minus sign right here, minus 7/2, because the b over 2 is a minus 7/2 all square. That's how I recognize this left hand side into a perfect square right here. And once again, how I can do that so quickly, you must review that video lessons of mine, because I delivered that lessons prior to this particular lesson right here. The right hand side remains equals 1/4. All right, and so now upon successfully turning our left hand side into a perfect square and making that perfect square equals 1/4, okay, then we can use the square root property, which is another lesson that was given prior to this particular lesson right here. So by square root property, I am going to take the square root of both sides and making it now x minus 7/2. No more square, but that equals plus and minus the square root of 1/4. And so at this point, the plus and minus square root of 1/4, and anyone learning up to this lesson must be fluent with how to operate with square root. Square root of 1/4 is a 1/2. So now we're looking at really two equations. On one hand, x minus 7/2 equals the positive square root of 1/4, which is a 1/2. Or, on the other hand, x minus 7/2 equals the negative square root of 1/4, which is negative 1/2. And so now what I'm doing to each of these two equations, I'm simply adding 7/2 to both sides. 7/2 added to both sides, 7/2 added to both sides right there. Okay, and so now that's making it, now I have to use this very narrow space of my board right here, but 7/2 added to both sides cancel the 7/2 on the left hand side, so that's making it x equals, and now 7/2 plus a 1/2, making it 4. And for the other one here, we're looking at add 7/2 subtract 1/2, x equals 7/2 subtract 1/2, that's making it 3. And so on one hand we have found x equals 4, which came out from this, and on the other hand we came out with x equals 3. All right. But so after recognizing this, the left hand side to be a perfect square right here, then we apply the square root property. Okay, but that was how we've done the complete the square method. And so as a brief reminder, that magic number that I wrote in red ink right here came out from the square of b over 2. And so that core steps right here. The first step, we subtract the constant term to the opposite side. Then we added the square of b over 2. And make sure to include the signs with b. It says b right here. That means b could be negative, like how I had in my example right here. So we added the square of b over 2 to both sides of our equation to produce that step right here. And now that left-hand side step, we've learned from that earlier lessons how we can recognize that instantly into a perfect square. And then we apply the square root property. And then we produce two equations and solve for it. Okay. Okay, so at the end of our example 1 right here, it came to the following generalization of how we can complete the square method. So the complete the square method centralized on the idea of the equation has to be in standard form with leading coefficient 1. Okay, so allow me to start out with the equation being in the form of x squared plus b, and b could be negative, plus bx plus c equals 0. Okay, and so the first step, okay, we subtract it, right? We subtract the constant term in generally is the constant term c right here. Subtract c from both sides of our equation. Okay, and that leads to produce x squared plus bx equals negative c. That's the first step. And we subtract c from both sides of our equation to produce x squared plus bx equals negative c. And so the step 2 that we did right there, okay, right at that current step, we're going to add that magic number there is going to be the square of b over 2. We're going to add the square of b over 2 to both sides of the equations. All right. And so adding both sides of the equation right here. And so we're going to come out with the following equation. X squared plus bx plus b over 2 all squared equals whatever the answer of minus c plus with the square of b over 2. But then from that one right here, then we can, in step 3 and later, right? In step 3, right? Left side is expressed as what I did there, x really plus half of b over 2 all square, and we equals to, and the right hand side is minus c, whatever outcomes that come out from minus c plus b over 2 all square. Okay, and then from that point on right here, then this equation right here, we're going to just go ahead and apply the square root property, and the later steps is just simply apply the square root property, which is also delivered in an earlier lesson. Okay. All right, so now we're getting into our example 2 right here, and I would like to enhance and push it into a further experience in terms of how we can solve a quadratic equation using the complete the square method right here. But before I begin, observe that this equation here right at the beginning, yes, it's in standard form, but leading coefficient is other than 1. Okay, the leading coefficient here is simply not 1. So that's something to note about. The lead coefficient is not equals 1. Okay. And so I emphasized earlier throughout example 1, and we came to the general methods, that the method of complete the square is only best used when our equation is in standard form and with leading coefficient 1. Okay, but the one we're having here obviously fails that requirement. Leading coefficient equals 1 because the leading coefficient here is other than 1. But we can still apply the method, but we have to have some do some treatment. Okay, so here's the treatment before here's some work around before we can actually apply the complete the square method. So with our equation at start, 3x squared plus 8x minus 3 equals 0. I'm now going to bring the constant term. Subtracting negative 3 means we add that to both sides. So here I'm subtracting the negative 3 means I'm going to add 3 from both sides. The goal here is to bring that constant term to the opposite side. So that's now making it 3x squared plus 8x equals 3. So we're still having that first step similar to the instruction. we bring the constant term to the opposite side. Okay, but now the extra step before we go on into the second step by adding the magic number. So before you can do some magic number over here, this is what we need to do. I am going to divide both sides by the leading coefficient. Now it happens to be the leading coefficient happens to equal to the number on the right hand side, making it a little hard to recognize, but the 3 that I'm dividing both sides from, that really is the leading coefficient that I'm dividing. So that's how we treat an equation that's in standard form but leading coefficient other than 1. Anytime you want to use the complete the square method here, we have to divide both sides of our equation by the leading coefficient. So dividing both sides of the equation by the leading coefficient leads to the following equation. Our resulting equation becomes, so now 3x squared divided by 3 gives me just simply x squared. Now its leading coefficient 1. 8x divided by 3 gives me plus 8/3 x. And now on the right hand side, I'm looking at 3 divided by 3 is 1. So the equation is reduced down to an equation where it's ready for applying the complete the square method right here. And so now our equation at this point is reduced down to simply x squared, leading coefficient 1, x squared plus 8/3 x equals 1. All right. And so now in that way, let's do a quick little scratch work right here. This is our B now. This is our current step now. This is our B really, because this is the B that's really ready for the complete the square method. So now our B here is going, so now the magic square is a B squared over 2. Okay, B squared over 2 in this case is, and this is on scratch work, it's just 8/3 over 2 all square, but 8/3 over 2 is 4/3. 4/3 all square. So, and 4/3 all square is really 16 over 9. So now I'm adding 16 over 9 to both sides of our equation. That's the magic number I was talking about, but now hopefully it's no longer a magic. It's simply just as a generality, B squared over 2 all square being added to both sides of our equation, or the square of B over 2. But be careful, the B here, I really enforced it. At this point, the B here is the B that's corresponding to our quadratic equation in standard form with leading coefficient 1. Okay? And so it's B over 2 all squared added to both sides of our equation. So now our equation will be, the right hand side is recognized as 25 over 9. And you can just easily apply the math by adding 1 with 16 over 9. The left hand side here, once again, applying what we have learned from the earlier lessons on recognizing a quadratic expression or a polynomial as a perfect square right here. Now I see this polynomial here on the left hand side as the following perfect square. X plus 4/3, okay, all square. X plus 4/3 all square equals 25 over 9. All right. Then with our equation at this point, x plus 4/3 all square equals 25 over 9. I can now at this point start using our square root property to find the solution to this equation. The square root property says this equation will become x plus 4/3 without the square equals plus and minus the square root of 25 over 9, which essentially gives me two separate equations. One of them is x plus 4/3 equals a positive square root of 25 over 9, which is a positive 5 over 3. Or we have another equation, x plus 4/3 equals the negative square root of 25 over 9, which is 5 negative 5 over 9. And now for each of these equations, I can go ahead and do the usual math. We subtract 4/3 from both sides. making it x equals 5/3 minus 4/3. And this equation here further becomes now 5/3 minus 4/3, making it 1/3. That's one of my solution. Or from the other equation, subtracting 4/3 from both sides, we make it x equals minus 5/3. This should have been 5/3. Minus 5/3 minus 4/3. And so x here will become minus 3. And that's how I have come to another value here. And so now I'm saying that this equation from the beginning now has two solutions. One of it is x equals 1/3. The value, this value for the unknown x will make the equation the equal 0. Or with that other value of the unknown here, it will make the equation satisfied. Okay, so we have found two solutions. All right, so now we're getting into the method that we can solve a quadratic equation by factoring. So this is one among the three methods of how we can solve a quadratic equation. So factoring is the key right here. All right, so it allowed me to bring in one example to illustrate the idea, and then after the example, we are going to generalize that into an actual instruction. All right, so this is our first example over here to show how we can solve a quadratic equation by factoring. And so just like how I begin with the solving a quadratic equation, the general idea here, then before we can use any of the technique, before we can use any of the methods to solve a quadratic equation, make sure to put our equation in standard form. Okay, so our equation here in this example is already in standard form. Ax squared plus bx. So a here is 1, b here is 5, and c is minus 24. So our equation here is already in standard form. And so just like how I said it earlier, any of the methods must be used after the equation is already in the standard form. Okay, and then so now here's how we're starting it. X squared plus 5x minus 24 equal to 0. So in order to use the factoring method, in order to apply the factoring method to find the solution of this equation right here, anyone is required to be fluent with the skill of how you can factor a polynomial. And so now the polynomial specifically I'm looking at here is this polynomial on the left hand side. And left hand side is just how I'm writing it here. Basically it's the polynomial on the side that's opposite to the 0. The polynomial the polynomial from our quadratic equation that's opposite from 0. So now this polynomial here, x squared plus 5x minus 24, is the one targeted to be factored. Okay, and so allow me to proceed, assuming that the viewers or students viewing from this lesson have already been fluent from factoring. And so with this polynomial right here, I can easily factor that into x plus 8 as one factor in product with x minus 3. And so now the complete factor form on the left hand side here, the product of x plus 8 and x minus 3, all of that here equals 0. And so the equation here is rewritten as equals 0, but on the left hand side right here we have a product of x plus 8 times x minus 3 equals 0. It's the same equation, it's just we have rewritten that polynomial on the left hand side here as in complete factor form. All right, and so now after factoring out, then this is what we can do right here. We have what's so-called a product property. The product property allows me to, now as long as we have a product equals 0, then each factor each factor. So the first factor is x plus 8 is equal to 0. Or the other factor, x minus 3 must equal to 0. The logic goes as following. For any product to equal 0, then one of the factors must equal to 0. One of the factors must equal to 0. That's the reason why from this overall equation we have let down to either x plus 8 must equal to 0 or x minus 3 equals to 0. One of the factors must equal to 0. That's why we had let down to the two equations here. It could be this as one possibility, or it could be the other one being equal to 0 as another possibility. And so now we have produced for ourselves two little equations. And so now proceeding with this particular little equation here, I'm subtracting 8 from both sides, producing x equals minus 8. And now advancing over to this other equation, I can just simply add 3 from both sides, making it now x equals 3. But now if we're reading each one of these two little equations here, what it says now is that on one hand, or in one possibility, x, the unknown, equals minus 8 will make this equation x squared plus 5x minus 24 equals 0. Or on the other hand, as another possibility, x, the unknown, may equals 3 to make this left-hand side x squared plus 5x minus 24 equals 0. All right, and that's how we have used the factoring method. Right? We factor the side that's the polynomial, now specifically the quadratic expression on the left-hand side right here, the side that's opposite from 0. We factor that into a complete factor form. And then from there, the technique here is that as long as we have a product equals 0, then at least one of its factor must equal 0. And that's how we led to these two little equations right here. Okay, simply because we added up with two factors here. All right. All right, so let's now write down the generality of, or the general instruction of how we can solve a quadratic by factoring. Okay, so simplest way from start right here, we're starting out with an equation being in the form of a standard form, ax squared plus bx plus c equal to 0. Okay, the first step here is to factor, right? Factor completely the quadratic polynomial. Opposite from 0. Because I hate always saying the left-hand side. So basically, once you have put your equation, your quadratic equation in standard form, 0 may be on the left-hand side and the quadratic polynomial on the opposite side. Or 0 can be on the right-hand side and the quadratic the polynomial is on the left-hand side. So the quadratic polynomial could be either on the left-hand side or the right-hand side, but mainly it's opposites from 0. So our main goal of step 1 right here, our main core step right here is to factor out completely the quadratic polynomial that's opposite from 0. Okay, and once again, provided that our equation must be already in standard form. Okay, and then from step 1 right here, after factoring completely the quadratic polynomial opposite from 0, all we do now is that we're going to set each factor equals 0 as a so-called sub-equation. And then in step 3 right here, we're going to solve each sub-equation. All right. All right, and so now we're setting ourselves into example 2 right here so that we can really formally repeat the steps that were written, the steps of the instruction that were written on the other board right there, and apply that into this particular problem right here. Okay, so now with our equation being already in standard form, the quadratic polynomial is on the left-hand side in this case here, but the point is, on one side is a quadratic polynomial, on the opposite side it's going to be a 0. So now the real first step, I'm going to go ahead and factor the quadratic polynomial completely, whichever that quadratic polynomial that's opposite from the 0 like that. So now, again, assuming that anyone viewing the lesson here has already had some good background with the factoring, then this polynomial here, this quadratic polynomial here, okay, can be factored into x minus 1 times 2x plus 3. And all of that here, that entire product is equal to 0. So that is our step 1 right here. We factor completely the polynomial, the quadratic polynomial opposites from 0 into a factor product. Okay, and then after factoring completely the quadratic polynomial, the opposite from 0 right there, we are now going to set each of our little factor, set each factor equal to 0. That's why I produce on one hand x minus 1 equals 0, or I have another sub-equation, 2x plus 3 equals 0. This is the reason for that is that I set x minus 1 as one of the factors equals 0. And I have another factor here, so I have produced 2x plus 3 equals 0. And so now on each of these sub-equations that I have produced right here, then specifically for this first one, I'm going to add 1 to both sides, making it now x equals 1. So what it reads now as one possibility is the unknown to this equation, the unknown for x, the unknown from this equation may equals 1. That will make the equality here satisfied. On this sub-equation right here, I can solve that by subtracting 3 from both sides, making it 2x equals minus 3, and then we can divide both sides by 2, making it x equals minus 3 halves. So what it says now is that as another possibility, the unknown from this equation may equals minus 3 halves. That will make equality of this equation here holds true. All right, and so that's how we apply the steps in the method that's so-called solving a quadratic equation by factoring. All right, so in here we're looking at how we can solve a quadratic equation by the method that's so-called using the quadratic formula. Okay, so in this specific technique right here, in this specific method of how we can solve a quadratic equation, allow me to bring in one unique formula. It works anytime and anywhere for any quadratic equation. Okay, and so allow me to bring in the first example so that I can illustrate the idea of how we can use that unique quadratic formula, and then we can, after the example, we can write down the generalized quadratic formula. Okay. All right. So in this first example, allow me to demonstrate how I can use what's so-called the quadratic formula into solving this quadratic equation. But so now, just like what I said in the introduction to solving a quadratic equation, then any of the method to solve a quadratic equation must be started after the equation has already been put in standard form. And so now, thankfully, our equation here is already in standard form. So now we can start immediately using the quadratic formula to solve and to find out the unknowns here, the unknown or the unknowns that satisfy the equality here. All right, and so everything depends on just simply one unique formula. So that formula is as follows. With our equation being in standard form, ax squared plus bx plus c equals 0. We can find x by the following formula. Minus b, which is that value, but now we purposely do minus b. So b itself could be negative, but now we go minus b plus or minus the square root of b squared minus 4ac and divide that by 2a. So this one unique formula truly is two separate formulas. One formula says one solution for x equals minus b plus the square root expression here all over 2a, the product of 2a. And separately we have another formula, minus b minus the square root expression then over the product of 2a. And so with that generalization that I wrote right before getting into the problem here, the only responsibility I need or anyone need to take here is to recognize who's A, who's B, and who's C in our quadratic equation. Okay, so in this equation right here, leading coefficient, the coefficient that comes with the x squared term, A is simply positive 1, because even though it was not written, but it means 1 times x squared, so A equals 1. B in our equation here is positive 9, and C in our equation, which is a constant term, is positive 20. That's everything we need. The only responsibility we need here, be able to recognize the A, the B, and the C coefficients and constant term. Okay, and so now in that way, really, I'm looking at the following. As a setup right here, we can do x equals minus b, the formula set minus b, so minus 9. Okay, so anytime I'm substituting values into a formula, into a variable in the formula, I tend to put that in parentheses. So the minus here comes as part of the formula. So minus the value of b plus or minus the square root of, so now I have b squared, but b here is 9, so I 9 in parentheses square, minus 4 as part of the formula, times a being 1, times c being 20. This entire expression b squared minus 4ac is contained completely inside of a square root expression. And all of that here is divided by 2 as part of the formula, the product of 2 times 1. Okay, and so this formula now is indeed, as I have explained earlier, this formula here is indeed two separate little formulas. So on one hand, we're looking at x equals, and so now I can start doing calculation at the same time right here, minus 9 plus the square root expression here. Okay, and so inside of the square root, and we've learned and already got fluent with square root prior to this point right here. So the expression here entirely says that we must finish out the calculation, the computation that happens inside of the square root. Then we take the square root afterward. And so 9 squared is an 81 minus 4 times 1 times 20. So all of that 4 times 1 times 20 here is 80. So 81 minus 80 giving me square root of 1. Those two terms, that sum is divided by 2 because the product 2 times 1 in the denominator is 2. So what it says here is that this starting formula at the beginning point right here, after substituting in A, B, and C, it really produced for us two separate different formulas. X equals minus 9 plus the square root expression over 2. And we have another one, but the logical keyword here is or. So on one hand, the solution comes out from this formula, or the solution comes out from the other formula. Minus 9 minus the square root of, the expression inside once again comes out with 1, but here we're looking at minus 9 minus the value of square root of 1 and over 2. All right. I still want to retain this general formula here. Allow me to use this little space that remains on my board here to finalize the two answers. In one of the formulas, it came out that it came down to x equals negative 9 plus the square root of 1 over 2. And so now we have learned about how we operate square roots together with other operations. So now it must be done that we take the square root of 1, which gives me 1, plus a negative 9, which gives me a negative 8, all over 2. So that gives me altogether a minus 4. That is one solution. Or, on the other hand, the other formula came down to minus 9 minus square root of 1 divided by 2. Once again, we take the square root of 1 first. That's making it 1. So minus 9 minus 1, making it minus 10 over 2. Our final answer, another final answer here is minus 5. So what it says now is that for this equation from the beginning, x squared plus 9x plus 20 equals 0. On one hand, the unknown equals negative 4 as one possibility. The unknown may equals 4, which will make equality here holds true for this equation. Or on another hand, the unknown for this equation may equals negative 5, which will also make equality hold true for this equation right here. All right. And so that's how we used our quadratic formula. And this formula here is famously now called the quadratic formula. But so I would like to re-emphasize one more thing, that this formula really means, or truly means, two separate little formula. On one hand, you have one solution obtained as minus b as a formula. Minus b plus the square root expression, b squared minus 4ac all over the product of 2a. Or the solution, the unknown x value, can be obtained by the other formula, minus b minus the square root of b squared minus 4ac all over the product of 2a. All right, so now we are heading into example 2 for that specific method of how we solve a quadratic equation by using the quadratic formula. Okay, and so now let me just repeat what we have done, just like how we were doing it in example 1 right there, basically just the steps. So the only one step really is to recognize the coefficients a, b, and c from our standard equation, from our standard quadratic equation. And so a in our case is 4. B in our equation here is minus 4. And C in our equation here is minus 3. And so the next step now is just simply to put all of these values into the quadratic formula. So the quadratic formula says x can be found by minus b. But so here b is negative 4. So this minus sign is part of the formula. The negative 4 is the actual value of b. So minus negative 4. So I put negative 4 in parentheses. Plus or minus as part of the formula. Now we have the square root expression. B squared, which is now minus 4 in parentheses square, minus 4 as part of the formula. A is 4 times C being negative 3. And you can see in my style, I use parentheses very carefully anytime I'm substituting a value into a formula. And so that, whatever that comes out, we'll divide it by the product of 2 times a, which is 4. So 2 times 4. All right. And so, in how I explained that earlier, so now this formula really gives me two different answers. So on one hand, x equals minus negative 4 plus the value that comes out from the square root expression. And so let's quickly calculate that. Minus 4 all squared is a 16, minus 4 times minus 3 is a plus 48. So 16 plus 48 is making it 64. So now we're reading minus negative 4 plus the square root of positive 64. And we're dividing that by 8 because 2 times 4 is 8. But what's primary here is the minus b plus the value of the square root expression. Or, on the other hand, x can be found by minus b, which is minus -4. Now subtract the value of the square root expression, but inside the square root expression now it is 64. And we will get to that final value of the square root later after. All over 2 times 4, making it 8. All right. And so now in my next step, minus -4, making it 4 plus, now square root of 64 gives me 8 all over 8. That makes it, so 4 plus 8 is a 12 divided by 8. That gives me 3 halves. That means on one hand the unknown is found to be 3 halves. Or what it says here is that in order to reach equality of this equation right here, the unknown as one possibility may equals 3 halves. Or, on the other hand, now this computation here comes out x equals now minus -4, making it 4, minus the square root of 64 is 8. 4 minus 8 divided by 8. That will all together make it minus 1 half, because 4 minus 8 is a -4 divided by 8. All reduce it down to a -1 half. Or it leads down to x is equal to -1 half. So what it says now is that, or as another possibility, the unknown of this equation right here may equals -1 half to make equality hold true in this equation. Okay, but generally speaking, this is the way how we apply the quadratic formula. The only responsibility here is to be able to recognize A, B, and C from our equation in standard form. So we always have to put our quadratic equation in standard form before we can use any of the techniques. Okay, and then the formula is here.